My name is Tore Banke, and I'm Director of Sustainability here at BIG. I'm trained as an architect. I have a background, a PhD background in computational design and performance analysis. And I'm very much constantly kind of in search for how we shape our future. So with the constraints of both the social aspects, environmental aspects, and economic aspects. I think I would like to start actually from where I grew up, because I think it says a lot about my motivation and where I am now. I grew up in the northern part of Jutland, close to the sea, and very much kind of surrounded by nature. And I used to say that, well, it was not like a kind of a common childhood. It was more like growing up in an ecosystem where we were very much in contact kind of with the kind of resources that we were surrounded by. So to give some examples, my parents both had full-time jobs, but at the same time, they were also very visionary on several areas. One of them was that this is like in the late 70s, early 80s, where they raised one of the first windmills here in Denmark, and this windmill was not. It was actually kind of that there was a kind of a huge cable going into the house. So most of the energy that we consumed was powered by this windmill. It was like an industrial windmill, of course, much smaller as what we see now, but it was an industrial windmill, and after kind of the energy used from the house, it was sent to the grid. And I remember kind of, we had these kind of, you could kind of visualize, how much energy that was being produced. And we had this kind of red dot that was kind of indicating, when we, were kind of using the washing machine and the dryer and these things, right? So we were very much kind of in response to kind of what energy we were producing and our consumption. At the same time, we were also almost self-sufficient in food production. So we had a large area with kind of a vegetable garden. We were eating very much like what was in season, also saving for winter, and also had like animals, so like chicken and ducks and geese and sheep.
Amazing.
So really like kind of close to these kind of natural elements. And I think at the same time, my parents had a very big interest in architecture and design. So I kind of grew up with kind of the classic kind of design classics, and kind of got told about the anecdotes behind the design. So, like we know like the Danish classics of Wegner and Bruno Madsen, Paul Henningsen, and Arne Jacobsen. And so all of these anecdotes about, both how the relation between kind of performance, but also aesthetics. So that kind of gave me a great motivation actually to, start combining these things also in terms of, the environmental work that I'm doing right now. After I finished, like through my studies, this was kind of the time where, this is back in, my master's is back in 2007. And this was the time where, like, I mean, programming and visual programming has existed for a long time, right? And but it caught my interest. At this time, we were working with, I was sitting close to the research center, CETA, Center for IT and Architecture at KAACADEMY here in Copenhagen. Mm-hmm. And they just started up, and I borrowed one of their licenses for MicroStation, the generative components.
Generative components, yes.
Yeah, exactly. And I think, I got like a manual that was like this thick, right? And
yes.
And I kind of experienced also, trying to tap into their, forums and these things, and building these kind of relationships and parametric design, what we called it at that time. And I also found out, the difficulties there, because it was very much like an isolated kind of community, and a lot of the companies that were using these tools were, they were the top businesses, and it was not really spread out to, the communities.
Exactly.
Like students and smaller practices. And around that time, we saw a shift. So that was when explicit history, that then became Grasshopper later on. It suddenly kind of showed up, and I just immediately saw how it just opened up, new possibilities for not just for architects, but also for engineers. And I started experimenting with this in terms of kind of environmental analysis.
Mm-hmm.
So I remember one of my first projects was actually, it was we have a lot of coast here in Copenhagen, or here in Denmark, and a lot of these industrial areas, they're being transformed into new areas for living, and I found some old silos that I wanted to reuse, and then I wanted to have this I wanted to make this building that was shaped with some of the traditions from the old kind of shipbuilding industry. So I kind of I made this program, like where I at this time we were kind of throwing between all kinds of different types of software, where explicit history and Grasshopper was kind of the core, but it was also limited, but we threw it between different types of software, and I was kind of capable of kind of controlling the geometry. So I kind of got inspired from the old kind of shipbuilding techniques, where you use single curve kind of standard elements, and then controlling the geometry into something that was kind of controlled, but it was curved and shaped in particular ways, and then using this technique to shape it according to daylight, depending on different program types. And that was kind of the beginning for me, where I was like, at this time, trying to control something like 5,000 facade elements where I could kind of I could control the geometry, but also the performance aspects. And so this was kind of the beginning of my kind of motivation of and I saw there was really some great opportunities here for collaborating across kind of different I think like when Grasshopper kind of got its birth, immediately we saw this incredible forum, that was it was between practices, it was between researchers, it was between different types of professions, and everyone had different contributions to this platform with their different roles, their different interests, their different perspectives. And that was also what I saw through my PhD after the master. This was actually a great opportunity to do collaboration across and inform design from earlier on. So the thing about having something that suddenly was so intuitively that on one screen you could have the very Rhino kind of viewport, where you could sit and you could sculpture, you could investigate the aesthetics, the spatial relationships, all of these things, at the same time having the very kind of measurable kind of data and inputs from especially kind of the engineering professions. Suddenly and in combination with having a forum where people could kind of discuss and contribute to this, suddenly you were able to develop at an incredible speed. And that was what I kind of experienced through my PhD, that this suddenly became a common platform for exchanging these things, where in the past it was very much happening in these silos, but now it was much more fluent, and the innovation was happening much faster. And I mean, at the same time, what it also gave the opportunity of was to actually create some workflows that were very precise depending on what you wanted to achieve. And that's also what we see now, that all practices work with Grasshopper, on different levels. But what you're seeing now is that you have people that are working, as architects, where they are more like generalists and has
Exactly.
basic skills. At the same time, you also have computational design specialists that are kind of highly advanced, and they work on GitHub and kind of more advanced things. You have people that come with really kind of specialized skill sets like engineering and kind of environmental kind of design. And you also have people like, for example, now we have people that are they are programmers and they they do software development, and everything is tied together in these computational workflows. So I think that's really what has developed. It's actually given the opportunity to to grow and yeah. I think sustainability has always been an interest for me, like from my childhood and my kind of my exploration through my education. So I think it has always been there. I think when I started to see kind of the computational design grow, I immediately saw that there was a really great potential to overlap those things, because it's also about like when we talk about sustainability, environmental design, whatever we call it, it's a lot data driven, and it's about also combining research and kind of weather monitoring, research about what happens in the ecosystem, what is it we need to benchmark up against, and doing predictions for the future. And that's quite that suddenly becomes quite complex, and that fit very well into computational design in general, right? Because that's where you can handle all of these things very, very nicely, and it's something that's quite difficult for kind of humanity to deal with, because this huge complexity. So actually combining those two things, both the visual and then the data, it gives some incredible kind of opportunities. I think a lot of things have changed. Like if we look back maybe 10 years ago, I think the industry was very much focusing on kind of performance aspects, here and now. How can we make something that performs well, for example, with energy, right? And I mean, that's really, really good. What we are seeing now is that we also realize that that's not enough. We need to look into the entire lifetime of the building. So suddenly the challenges becomes it becomes to a greater complexity, and that's what we are starting to model. And it also means that we need to invite more. We need to invite more kind of people into our design process. So for example, like now we have been developing for nearly 2 years for making our own life cycle assessment tool, because we're seeing that there's a lot of tools out there, but the difficulties of modeling something to such a high kind of detail is very, very difficult in the early design stages, where we know that this is where we make the most important design decisions. And it's really in the early phases where we have design impact. So we need to use these tools. We need to use all of this knowledge and data that we have, and we need to embed it early on in the process.
In the design process.
So it's actually a way to also kind of capture this knowledge that kind of get built up through the process, and actually make a feedback loop to the earlier stages, so that we can develop and we don't forget the things that we have learned going through these projects. And that's where the computational design play a huge role. If if we look at it from an environmental perspective to start with, there are huge advantages of reusing these structures or even these materials. At the same time, the way that the economic system is set up, it comes at a price. So it can sometimes be difficult to compete, proposing some of these, these concepts where you reuse. And I think, now we are seeing also kind of, some global pushes for like CO2 taxes that, will be embedded soon. We have one here in Denmark that's coming for starting, with taxing industry, right? But I think we will see this grow even more, and I think it's an amazing opportunity to actually also give the possibilities for making even more reuse, and also giving new businesses an advantage, right, of coming in with a more environmental product, right? So but right now there's a bit of an unbalance in those things, because a lot of these materials or building techniques, they are economically like my team, we are pushing for many initiatives, right? We are working with environmental analysis, that's like both indoor comfort, outdoor comfort, wind analysis, daylight, and those things. We are working with different certification, global certification types. We're working with LCA, material research. We're working with energy design. And we're working maybe with 70 projects a year. So we're really involved in most of our projects here. And like one of the things that that we're pushing a lot for is that we have a project right now. It's a smaller project, but it's a project where we're trying to use as many bio-based materials as possible, and we are trying it out with different smaller houses where we experiment with different types of bio-based materials. We are not there in terms of like self-growing architecture yet, but it is materials like bio-based materials like insulation materials. So for example, sheep wool and kind of seaweeds and cork, for example, wood, of course. We also have with all types of reused materials, reused plastics, different types of materials that are quite new to construction industry, but we are trying to see both what are the environmental kind of aspects of these things, but also what are the architectural qualities that these materials give us. So it's coming up soon, and I think what is also amazing is that this is also something where the client is very ambitious, and I think we have a lot of great like it's also about starting to really collaborate a lot across, because this of course also means a very close collaboration with the people that are providing the material and also the data about the materials, for us to be able to
amazing.
To estimate the environmental aspects, and also in terms of buildability. So we are moving into new territories with for example fire, moisture, all of these things. So I think this is there are some interesting aspects there, and at the office right now we are building up a huge kind of physical material catalog. At the same time, we are gathering data about this material, and we are feeding it into our life cycle assessment tools, so that we also have it in a digital format. But I think it's important to also be able to kind of have the material in its physical form to be able to implement it into architecture, so that we also work with the aesthetic kind of quality. I think it's both sides. It's very much both sides. I mean, we are seeing the need for these materials. Also because, like in Denmark, we have a regulation coming up 1st of January with a CO2 budget. So you need to meet a certain CO2 budget for a new building. And there is
to receive certificates, to receive
to get a building permit, and this is kind of a national kind of regulation to be able to live up to the goal of the Paris Agreement. So it taps into the national strategy, and of course we can see that this budget is decreasing, every single year, and in a few years. It will be evaluated to see if it needs, to be modified, if it needs to go even lower. So it's something that's coming. We are also seeing a demand from society that this is something that is needed, and we see it from our clients. We also see it from our, the investors and the banks that are supporting our clients, and of course the politicians and society in general. So the title will be climate responsive architecture. So it's really about, how do we bring, environmental aspects into architecture at the same time increasing the quality of life, or you could say even life forms. So how do you combine these things? Because I also believe that if you're able to do that, and you can succeed that, and people don't feel that they are, downgrading their living standard, then you actually have a huge potential to grow a lot of these, kind of these concepts. So that's what the talk is going to be about, and I'm going to zoom into different projects where I think that we have kind of created something that at least some attempts, where we see this actually gives quality to both aspects. And,
awesome.
And also in terms of, the economic aspect that of course we can't forget either. Yeah, so I think now it's just been summer, so that's been a great time to actually dig into, some books. I think one of the very great inspirations that I read was The Life of Plants by Emmanuel Kocher, and it's a quite he's a philosopher, and it's quite an inspiring book talking about kind of the where humanity is coming from, and all the way through, like where does life come from, and the involvement of plants, and how plants kind of succeed to collaborate and evolve through millions of years. And it's quite inspiring to read, because you kind of immediately see how we are not kind of detached. We are not detached from nature. We are part of nature, and you could then start to speculate about how do we create greater synergies with this, and I think it also lead me to kind of the next book for recommendation, which is, unfortunately, I think it's only in Danish, and I need to, now I just kind of directly translated it. It's called kind of The Nature of the Indoor Human Being, and it's by Cecilie Ruborg. She's an anthropologist, and it's quite interesting. She kind of speaks. She's been out kind of talking to all kinds of people about their relation to nature. So she's been out in nature and discussing people experience with nature and where it comes from. And she very nicely speaks about kind of how we through history have developed, maybe through from the Industrial Revolution till now, have developed this this building culture where we have taken control, right? Like through control with the the natural light, the air, the temperature, and how we have created this environment where, like depending on region, we are, more than 95% of the time indoor, right? And how she discussed how this might relate to our difficulties coping with, for example, climate crisis, because we are so much attached from nature. And if we get a closer connection to nature, she believes that we'll be much more kind of capable of coping with some of these challenges. So that's also a motivation for me. I think, one thing is to make design that's, has, a lower kind of impact on the ecosystem. But another thing is also to invite nature more in. So that's also what we are trying in many of our projects, to actually make these synergies where, you get a closer kind of connection. And just to speak about some of the work that we're doing, we are doing a lot of work where we are looking into passive design techniques, where, of course, that's about, for example, natural ventilation, daylight, and these things. Of course, it has some environmental aspects. It lowers the energy production and or the energy consumption and these things. But at the same time, it also gives a closer connection between nature and humans, and looking into what are then the qualities of these synergies. Maybe the last one that I'm kind of in the middle of right now, and that's a book. It's a little bit scary. So if you don't like scary stories, then don't read that one. But it's called Our Final Warning by Mark Lynes. And that one is
a horror movie, or
no, it's actually it's 100% scientific based.
Okay.
So there are no kind of speculations here, because when we look at climate change, depending on what how we go about it, and our strategies, and how fast we kind of go net zero.
Yeah.
Things can happen at different speeds. What he looks at is kind of just pure facts from the best we have from science. Looking at chapter 1 is called 1 degree, chapter 2 is called 2 degrees, chapter 3 is called 3 degrees, and then you can think about what chapter 4, 5, and 6 is about. But going in, looking across all the great science that's happening right now, looking in how will our ecosystem look at these different temperature rises. And I think it's really interesting just to kind of speculate about what scenarios is that we might see in the future, and what is kind of what's the importance also of working with these topics, and not just from an architecture point of view, but also the importance of collaborating across and actually distributing this knowledge. Yes, this was actually a thing that kind of I think many people kind of got new hobbies during COVID.
Yes.
I was kind of I'm very happy to have a summer house up on the North Coast, and where we kind of went in isolation, and there I got a hobby of I started spearfishing. And, of course, it also relates to my childhood, where I was very close to the sea. Mainly through my childhood, it was more about sailing and these things. So above, above water. But here, I've been, doing this quite a lot during the last few years, where I really feel kind of a really strong connection. I think it's also, I tend to go up before the family kind of gets up, and this is the time where you can be on the coast by yourself. There's not that many people, and you can really see how things change during the day, during the season. You start to get an understanding about what's the life of those life forms below the sea, and starting to continually kind of see new patterns. Where do they hide? How does the things change depending on the weather, and depending on temperature, what type of fish are there, where do they hide, and get behind all of these systems that are have been here long before we came. I think it's really about if just be curious and constantly be curious and ask questions, right? Because we it's only the imagination that is kind of stopping us from thinking about the future. And there's so much great work out there, and you just need to be curious about how do I get all of this knowledge, and how does it contribute to shaping the future? And I think we have so many great people that have all of this knowledge, and we just need to get it and get them involved into our work. So be curious about that, and then also be persistent, because we're working with if you want to shape something new, it's difficult, and it's difficult to make change. You need to be consistent, and you need to just constantly be able to push for what you believe in, and just find your superpowers, right? And just continue to grow those skill sets.
Exactly.
I think, yeah, and then just embrace complexity. It's we are living in a whole ecosystem that is
very complex. Yeah.
Yes, that is a complex network, and so be open for that complexity, and see the possibilities that it brings for shaping the future. Maybe just the last thing that I think it's also about just reach out. I mean, people are in general are ready to help, right? So just pick up the phone, call up the people that know something about it, and they will be happy to participate.